Hi, and welcome to Max Ed. This is the first episode of Max Ed Physics. But before we even get started, there are some common misconceptions about what physics is and what it isn't that we need to clear out. One of these being how physics relates to math, but also how it doesn't.
So, what is physics? The question itself can be mind-boggling. Why? Because the field of physics is vast. Coming from physis, the Greek word for nature, physics can be defined as the study of nature and the universe itself. It encompasses the studies of matter, energy, forces, and the motion of matter for both space and time. It zooms in on the quantum level and studies subatomic particles and quantum phenomena, but can broaden its scope all the way to the astronomical level, where it studies the universe itself. There's a widely spread but not always very popular illustration to this broadness, where physics is compared to chemistry, which mostly studies phenomena at the molecular level, and biology, which studies life, including cells, organs, and animals. Sometimes mathematics is thrown in at the very bottom to illustrate that all sciences at the very core can be quantified and described by mathematics. This is a handy beginner's guide to science, but as you become more knowledgeable within the sciences, you begin to realize that they're all just part of a bigger whole. Now perhaps you think that physics is just formulas and math. And there is truth to that, but it is so much more. Unfortunately, the focus in education often ends up being on the calculations and the mathematical understanding of physics. I like to think that those who stick to physics despite its hardships see beneath the sometimes intimidating surface. There's a beauty in the way nature and the universe work, and gaining an intuitive understanding of why things are the way they are can be absolutely mind-blowing. You don't need math or numbers to understand what speed is, or how it relates to distance or time. Nor do you need math to understand what a force is, and how it relates to mass or acceleration. Arguably, a physicist isn't always interested in the math at all. It's just that when we actually want to apply physics and invent useful things, or gain an even deeper understanding in some areas of physics, numbers are unavoidable. In fact, the surgical precision and accuracy of much of today's technology is possible thanks to both new understanding of physics and the other sciences, but also the people who crunched the numbers and applied the results. Let's take a look at one of the most famous equations in physics. Isaac Newton once said that an object at rest stays at rest until acted upon by an outside force. This is part of what became known as his first law. He then described this phenomenon with what became his most famous equation. The force equals mass times acceleration, or F equals m multiplied by ma, often written without the multiplication sign as just F equals ma. This is called implied multiplication. So if a force comes in contact with something that has mass, that object will accelerate in the direction of the force. The rest of Newton's law states that this object will now continue in that direction until an outside force acts upon it again, pushing it in a new direction. Or if that force happens to be equal and is applied from the opposite direction, the object will stop. This illustration is true in the vacuum of space, but here on Earth we have many forces acting upon us at all times, often keeping us in place or stopping us if we were moving previously. If humans ever plan on expanding into space though, for Newton's first law would need to be considered, since everything we manage to accelerate in space will just keep heading that way forever. Okay, so now to the more mathy bits. The equation we just discussed can be manipulated. In fact, your bathroom scales use a manipulation of this equation to calculate your mass. What do I mean by that? Well, to start off, let's just make sure we're on the same page. In math, you can calculate or rewrite an equation in different ways by doing the same thing on both sides of the equal sign. 2 times 5 is 10. If we divide by 5 on both sides, what happens? Well, 2 times 5 divided by 5 is the same thing as 2 times 5 divided by 5, which is 2 times 1, which is just 2. In the same way, this mathy magic can be applied to physics phenomena. If F equals ma, and we divide both sides by a, we get F divided by a equals m. So if we apply some force to an object and it accelerates by a certain amount, we will know its mass. This is how your bathroom scales work. They measure the force you push them down with and divide it by how much the earth is trying to accelerate you, which allows it to calculate your mass. Your mass is constant whenever you go, but if you want to calculate your mass, say on the moon instead, you would need to adjust the acceleration value in your scales accordingly. Otherwise, it will show that your mass is about the sixth of what it is on Earth. This, by the way, is a pet peeve of many physicists. Your mass is the same on Earth, but your weight is less on the moon. So this was an introduction to physics, with some basic examples of physics math and how forces work. I would really appreciate any feedback your viewers can give me, especially this early in the series, so feel free to leave a comment below. I hope I'll see you in the next video, which will go deeper into forces and how they affect objects. We will also have a closer look at some more applied examples. This is Max from MaxEd, signing off.